supports voice and real-time services on top of their data network. Right? So we have differentiated services, identify the traffic, quality of service, and it allows us, so this kind of sits on top of a routed MPLS core. Actually, two MPLS cores. That's how they're pretty crazy about redundancy and resiliency. They actually have a Sprint purpose-built MPLS network to support the voice network, and they have their own MPLS network as a backup. So all of this can fail over. So this side here represents Knoxville, their primary data center. This side represents Middleton, Wisconsin, their secondary. And right in the center, session managers. Right? We have distributed session managers. This here represents a SIP survivable branch. And we have 6 of these survivable branches around the country, all tied back in with SIP agents registering the session manager. So at the top layer of all of this is an IVR, ACD front end. And what we're doing is, because they couldn't get native SIP trunking in the amounts of trunks they need, we have 3,000 SIP trunks in each location. Well, in I believe it was in Middleton, the carrier couldn't supply 3,000 SIP trunks, right? And the services, the advanced services they needed on them. So what we did is we put audio codes, M3Ks, median 3,000 gateways. Each, they're actually redundant. We have 5 DS3s for the PRIs coming into both sides. We route those down through the session manager and back to the ACD IVR. So the way the calls are delivered from the core, or from the PSTN, they alternate calls, 1 for 1, between Wisconsin and Knoxville. So everything is live, everything is hot, right? The calls come in and they flow down through Session Manager, and we control the routing of all the traffic within the Session Manager, right? All of the agents are SIP out of the remotes, and they are all registered to not only Session Manager, multiple Session Managers, and a third branch survivable Session Manager in their local office. And that's very important, right? Because in the H323 world, you're registered to one gatekeeper at a time, right? One place. If that place went away, you had to go down through a list and re-register. The beauty of these phones, the SIP implementation of the SIP phone, the phones are actually simultaneously registered to all 3 places. So in case of an outage, whether it's a network outage with Sprint, a network outage of a dual home switch, whatever the case may be, the phone is automatically registered. There's no event at the phone. The phone's already there. It's registered. It knows Session Manager is there. Session Manager knows the phone is there. In case this complete office becomes an island, there is a small event, right? We have PRIs coming into the local office. It's SIP survivable, which is very cool. So this Communication Manager and Branch Session Manager fire up in case of a WAN outage, and it becomes the same phone system that they had when they were back in the core. Right? So it has this 1, 2, 3 levels of survivability with multiple layers of survivability within the data network. So Altura is doing all of this right now. We have all this equipment staged in Chicago in our labs there, and we've actually duplicated the MPLS network with our own routing, right? And so we're live testing all of this, and it's very cool. It's very resilient, and just the failover testing alone. The scenarios, there's so many scenarios. We're going through some test plans that are pretty intense and very detailed. So what I want to demonstrate here is that we understand, right, how to make a SIP network work.
Paul, when is your cutover? You're coming, isn't it end of March or is it?
April. April. We're actually installing Middleton and Knoxville at the end of the month, and then the call centers will start running in. Right, we're doing the WAN testing now. Altura is doing all of the network assessment for their WAN, and the numbers are astronomical. So to ramp up each one of these call centers is served by 2 DS3s with the PRIs, and in the cores are each OC12s. So to ramp up the amount of traffic for the network assessment is kind of daunting. Right?
How long has it taken you from I know you guys were in meetings for a year, planning this, at least a year, maybe more. But from the point when, okay, you guys said, all right, we got a plan, we're ready to go. How long has it been since that point to now?
I think that equipment delivered in end of January.
Of this year?
Yeah. Yeah. And this is all up and running in our labs already. Yeah. So we've got people like Ty, there he is. Ty up there last week helping us out. You know, we have guys that, engineers that work specifically on certain disciplines like AES. AES is a very important piece of this. That's application enablement, right? So from a CTI standpoint, we tie back into the IVR layer. So here's another very cool thing. So each one of these agents, they have a SIP phone, but they also have a client on their desktop, right? And all their phone control is actually done through the desktop. They could actually take that phone if they wanted and stick it in a drawer, right? And just have the headset. One of the really neat features of this implementation is third-party call control of a SIP phone. So up at this layer, up here, they can third-party call control this phone. So this may be a server in Middleton. This phone may be in Tulsa. And they can third-party control this by the agent hitting a hold button or a transfer key on their desktop. Will take that phone call from the phone and transfer it back out to, let's say, an outsourced call center in Jamaica, right? And that's compelling. I don't know anybody that's doing third-party call control of SIP phones at the same level that we're doing with VID. It's an amazing. It's cool. It's fun. It's really cool to see. So, just to give you a little information about some of the detail, there's the 6 locations. Knoxville, Tulsa, Cedar Rapids, Bolingbrook, Illinois, Waukesha, and Madison, Wisconsin. It's kind of high there. But just to give you an idea of Altura, we had to explain each one of the SIP and RTP call flows in order to help design the network. So just to demonstrate that we've done these things, we understand the SIP call routing and RTP routing, because we're talking to 2 different groups here. We're talking telephony group with the SIP and routing and how that's going to affect the signaling channels, and also, most importantly, the speech, the RTP. I talked a little bit earlier about how we handle, one of the advantages of SIP is limited uses of resources like DSPs and transcoding, right? One of the things they want to do here is bring the calls in from the carrier, go to the IVR at G711, right? They try and handle 60% of their calls within the IVR. If it has to go to an agent, you want to transfer that agent or the call out to the agent, re-invite from the gateway or the IVR back to the median, and natively send G729 across the network to the agent. So that does a couple things. There's no gate, there's no resource, expensive resource sitting on a gateway that has to be engaged in that call. And that's huge. If you wanted to do transcoding, if in a traditional sense, this call would have to go from here into a gateway and get transcoded and back out. Now you're holding up 2 resources that cost money, take space, take heat, take power, sitting in the data center or at the edge. We're eliminating that piece. There's something called, with SIP, there's a feature called SIP Direct Media, right, IP media. And that allows you to skip the traditional step of shuffling, right, a call from IP phone to IP phone. You usually have a gateway in between, right? And then once the 2 endpoints connect, the call shuffles. That's a complex process. eliminate that process by negotiating the codecs that we're going to use as the call is set up. So it eliminates some of the complexity in the network, it eliminates some of the hardware at the core, and it allows you to utilize the WAN more efficiently.
Is that it?
That's about it.
Geez, Paul, I didn't cover much.
Yeah, sorry.
What have you guys been doing in Chicago?